Okay, next step, the detail normal mapping, something we've also done in the first video. So I'm gonna look in one of the UDK packages for a detail normal map. So I simply look for detail in all of the packages. And a couple of those I find. Perhaps this one, ideally you would make your own, but this will probably work. Adding that one. I'm not gonna make that a parameter because I assume that the detail normal map will always be the same one. And as covered in the first video, we're gonna blend this one on top of the existing normal map. So this is a detail normal map. It's gonna be scaled very tinily, and it's gonna ensure that when we get very close up to the monster, we still see some fine detail. So this is a very small tiled one blended on top of the original. That's the setup. Also, I'm gonna add in support for scaling both normal maps. So I'll start with this one. I'm gonna add a constant tree vector, which will multiply with the normal map. And this will allow me to tweak the intensity of the normal map per instance. So if I type 111, it's the same as it was. But if, however, I type 441, the normal map gets more intense. You should never change the blue channel. The blue channel should always remain on 1, and the detail normal map should never be added up to the blue channel either. So if you're gonna scale things, if you're gonna multiply or add or do anything, whatever with the normal map, never modify the blue channel, only modify red and green. That's what I'm doing here. I've multiplied the blue channel by 1, and 1 times something is the same. 1 times 4 is still 4. So I'm not modifying blue, but red and green get stronger. I'll bring it back to 1,1 because I don't think it should be changed right now. And I'm gonna make this a parameter as well. Then I wanna scale the detail normal map. So I add a texture chord behind it. So I can now type the number of times it scales. So I'll type 20, it's probably too big still. And I will have to do more things to this in a bit, but here is a first start to it. Then I'm gonna multiply. Well, we could actually do the same, we can copy that one. And I'm gonna rename it then to detail normal map intensity. Same reason, this is the intensity of the detail normal map. And then, as also explained in the first video, we are gonna be adding this on top of the big normal map, on top of the unique normal map. But if I add this on top of that, then it will also add blue on top of blue. And as said a few minutes ago, you cannot be modifying the blue one. So what I'm gonna do here is I'm bringing in a component mask, and that component mask will filter out blue. So whatever goes in, it will only let these two out. So whatever goes out is only red and green. So I just lost my blue, the blue channel here. And then since I can't add this on top of that, since this is red and green and this is red, green and blue, I'm gonna make this back into a red, green and blue texture output by adding an empty blue channel on top. So what I'm gonna do here is, in order to complete it again, I'm adding an append vector. Append vector is basically the opposite of this. This takes channels out, this adds channels back in. So an append means it adds the next one. So if whatever goes in, if what goes into A is red and green, this will automatically add blue. If whatever went into A is only red, then B becomes green. So it always takes the next one missing. So by appending an empty number, just 0, I'm appending a black empty blue channel. So the output of this is again red, green and blue. And then we simply add these two together. So it's a simple add that combines both of these. And now, as you can see, we have detail normal mapping. If I were to change the intensity to 0, 0 for a moment, This is what it would look like without detail normal mapping. And this is width. As said, I think the scale is rather large still. It would probably be good with a bit of a smaller scale. And what would be even better is then, rather than actually typing the scale in here, is allowing the instance to change the scale. Because what we really are after is creating one master material, one material that does everything. And then we would like to make all the other characters, all the characters in the game should be based on this material. So all the characters in the game will be instances that are instanced on this master material. So therefore this master material must allow all those different instances to be able to configure the material as they wish. So pretty much every number must be exposed, must be configurable by the instance. And this right now is not configurable by the instance. So I'm going to turn this into something that's configurable as well. However, this we cannot right click and convert to a parameter. We have another way of doing this. We can multiply a text chord with two numbers, with a constant 2 vector. And now this will scale it. So now this affects the scale. You can see a change here. Now it's going to get really big. And now it's getting smaller. So you can also do that to change the scale. However, this is still not exposable to a parameter. If I convert this to a parameter, it will turn it into a constant 4 vector. Because there is no parameter version of a constant 2 vector. This doesn't have a parameter version. It will automatically become this then. And since you could do that, there's nothing really wrong about it, but I think it's slightly confusing that it has 4 numbers and it's only using 2 out of the numbers. So I'm going to do a different setup here instead, and I'm going to use 2 separate numbers, which are both parameters. So this is detail normal mapping scale x, or let's call it u. Now I forgot the group name. Let's see if this indeed was the name of the group. Yes, normal map. I'm gonna make them both 1, and I'm actually gonna change the default scale here to 28. And then we have to combine these two. We can't just do add, because then they simply add up. What we have to do here is turn these 2 separate numbers into what Unreal considers this, a constant 2 vector. And then again, we will do the same thing as we've done here with an append. We will turn these 2 into a single red and green output. And why do we need the red and green output? Because this is UV. So this expects 2 numbers. It expects 1 number for U, 1 number for V. This is U, this is V. So we're combining U and V into a single output, which then flows into in here, and this now allows me to scale it. Like that. The normal mapping is at this point actually complete. Can move this aside. We can also make a comment around it. If you select everything that should be grouped together and then right click here and do new comment, you get to create a comment box. You get to create this. And now when you move this box, everything inside of it moves automatically with it. So that's easy and very handy to move things around with. Then we will set up the reflection on the metal, as well as the rim lighting on the character. We'll start with the rim lighting. It's got a thing called Fresnel. So add this. And I'm going to set up a very basic version first, just to demonstrate what happens. So I have an add. I simply add this, actually add a multiplier in between. So I can set the intensity. And that simply gets added on top of the diffuse, and that goes to diffuse. Then as angle for the Fresnel, I'm going to use the normal map. It says here normal. So I'm going to bring this all the way down to the normal map. And now if I change the numbers to say 10, what you get is this. Obviously way too much. Scale a bit down more to say this. Not very pretty, but it gives you the idea. Now I'm going to improve further upon this. First of all, rather than just having a flat number, I'm going to add a constant tree vector here instead. In fact, I'm going to convert that to a parameter. And what I often do is, when I have situations like this, is multiply it twice. So 2 multiplies. 1 multiplies it with RGB, with the color. The next multiplies it with the alpha of the parameter. And the reason why I do this is the following. Let me type the name first. The reason why I do this is because now I can use the color picker, which is easier to use than typing the RGB values by hand, while at the same time I can use the alpha number to scale intensity. So I can do it like this. Now it's still a bit weird, it's not that pretty either. So what tends to work well, and this works better with metal than with skin, so it's going to show up best on the armor part later on, but I have to set up the base already here, is rather than simply adding it on top of the diffuse, I'm going to multiply it with a very strongly contrasted version of the diffuse and or the specular. And that's what I'm going to set up now. This is my ordinary setup, so usually when I deal with things like shiny plastic or metal, this in combination with the reflection setup we will do next, that's my usual way of doing things, and to my experience that gives the most crispest, most detailed, kind of shiny glossy result. It looks quite advanced, it looks nice. I think it looks slightly unrealistic. It works best probably for monsters and unrealistic stuff, but it does let it shine to my experience. So what I do now is I take a power, because I'm going to create a very contrasted version of the specularity, in fact. So the base of the power is the specular, which is inside the normal map. I have an exponent for that, which is just a constant 1 vector. I'm going to turn the vector, that constant 1, into a parameter. And that is what I multiply together with the Fresnel. And the reason why I do that, and I could have also used the diffuse, in fact I can use the diffuse right away. The reason why I do that is because then it will take over, then it doesn't just add a layer of Fresnel on top of it, because then it will feel very fake. It's just a flat layer that's laid on top. But because it multiplies together with the diffuse or the specular, it takes more of the detail and the structure of the surface into account, and it will look more realistic. It looks more detailed, it looks more alive. More like this. It's not just a layer on top. It actually takes the structure into account, as you can see. Now again, this works best on metal, and that's why I tend to use the specular for the power here. because the brightest parts in the specular are the metallic shiny parts, and those shiny parts should also have the most Fresnel. So I tend to use specular for that reason. So I'll reconnect it for a moment. And you can see here it already gets a more advanced look than what it was when it was just like that. Still too shiny. But again, I'm overdoing the numbers here, so it's more obvious in the video, in this tiny picture here, what's going on. It's a bit too much, or it's rather a lot too much, but for the sake of the video, this shows best what's happening. This adds a bit more of a redefined look, and it's the exact same way I handle something like reflection. So it's a very similar setup for reflection I'm using. So on top here, I'm going to handle the reflection. The reflection texture was added into the electricity. So I bring the electricity texture in. And now I have to make sure that this renders as a reflection texture. So the way to do that is by using a camera vector or a reflection vector. It doesn't really matter to my experience which one you use. I believe this one is exactly the same as this, except it's flipped upside down. I believe that's the only difference between the two. So I'll just stick to a camera vector. Then the next thing is that we're going to distort the UV coordinates based on the angle of the camera. That means we will have to do this. However, this won't work. See, it doesn't accept it. And this won't work because this outputs three angles, red, green, and blue, X, Y, Z. And again, this expects U and V. It only expects two things, and we're giving it three things. So I'm going to use a component mask again to get rid of the blue channel. This only lets through red and green. And if I do this, I get this effect. So when the camera moves, the texture moves along in a certain way. It's a very basic environment map. It's a basic reflection, basically. Looks kind of reflection-ish. So that's the base of my reflection map that I will add on top. Then I want to have control over how contrasted the reflection is. So I'm going to add a power in front. And I use the blue channel because the blue one has the reflection image. Again, I make this a parameter. Every single property should be exposed to the instance. There is a limit, however, as we're going through this. There is a limit on how many parameters you can have. I don't know the exact number, but I believe if you go over like 50, 60, 70, 80, somewhere there, at some point you're going to hit a limit and the engine is going to get really slow. The editor, rather, is going to get really slow. We're not going to get there though. We're probably going to end up with 30 or so parameters to deal with. So we should be fine. I'm going to raise the contrast right away. To my experience, that looks better. So it looks like this now. You can see this is what's going to create subtle highlights. Then it's the same setup as over here. In fact, I can copy this. I can copy the color thing here with the two multiplies. We're going to do the exact same thing again. Power goes into a multiply, which goes into a constant 3 vector converted to a parameter. This is just the color the reflection has, and this is the intensity the reflection has. Do I have to rename the parameter though? If two of these parameters share the same name, they get this different color. As you can see, if I were to now change the color in this one would also change. So as soon as they share the name and you change the value of one of them, all the other ones will go along. In this case, that wouldn't be a good idea because I want to give the reflection more of a blue color. So before I do that, I have to rename it. Okay, so now it looks like this. And then again, I will use the same trick, because rather than doing this is what we will eventually do. We will eventually add the result of this on top of the existing result. So we just keep adding every layer we do on top of the previous layer. So here's the layer, here is the add that combines the Fresnel rim lighting with the diffuse texture. So out of that combined result, I on top of that add the reflection result. But again, this is not finished. So this is gonna look really quite bad. Now we have this. Would work well for glass, but obviously not for mesh. As you can see, this is a little bit weird. So again, it's the same setup really as the Fresnel, so I'm going to do the same thing as well. I'm going to multiply this result together with the same power that I've used before. So together with the contrasted specular. And then we get this. Looks a little bit better already, still weird, but at least it takes a bit more of the structure and the detail of the surface into account. I'm going to reduce the contrast a little bit and increase the intensity a bit. And then the major next part is that we have to make sure the reflection only shows up on everything that's metal, which in this case isn't much. Later on the armor it will be better, but in this case it's only this arm bracelet thing. That's why we have this mask map. So this one contains, the blue channel here contains the two bracelets. We have to look at the texture as well. So that identifies, here are the bracelets used on the arms. So that identifies those two parts. So by multiplying this one on top as well, by doing a simple multiply of the blue channel on top, what we basically do is we lock down the whole effect to only those pixels that are white, or in this case blue, on the mask. You can see there's no reflection anymore on the body now, but the bracelet still has reflection. Now it's rather too blue, so I'm going to change the color. What we're after in general is subtle lighting, subtle accents. That's also what you can't achieve with just specular. You might have specular, which is nice for highlights on metal and such, but you will never be able to achieve a lot of tiny highlights moving around. Now it's still a bit aggressive here, but what you really want is tiny little highlights moving around on the metal. Again, this is too shiny. It's also saturated, as mentioned before. But that's what we're after, and that's what I always do with this setup. I try to get these subtle little details going around the metal, going around the scratches on the model. So it's not just one specular hotspot reflecting of the character, but it's a lot of tiny little highlights and darkness, dark bits moving around, reflecting off the mesh, reflecting off the metal, etc. One thing here is that we've now used the blue channel to multiply that with reflection. However, since the next one, the armor, is actually using the green one, we have to be able to switch from blue to green while in an instance without modifying the material. So we need to be able to expose which channels to use through the instances. And there's a thing here called a static switch, a static component mask parameter. So static component mask parameter, and that one is basically like a component mask, but then in a parameter version of this. So I'm going to add that in between, and then it will use the RGB output. And I'm going to enable blue here. But later on in the instance, I can take away blue and enable green, and then it will switch to the green one instead. This whole setup is the diffuse part. So I'm going to group this together and call it diffuse.